Cool. All right. Like I said, I want to teach this to you with using, I want to teach this to you guys using an exam question, because I find a lot with the calculations, you can't really scaffold it because it's not like theory and conceptual. So I might as well just jump straight into the math. I also find that I don't want to give you guys pre-learning for math because it's really hard to kind of teach yourself math stuff. So that's why I want you guys to see an example first. Something to keep in mind with this enthalpy calculation is that it's the same ideas, just working in different orders. So when you're doing your enthalpy calculations, we are trying to figure out energy, either energy released or unabsorbed, and potentially we're trying to figure out mass. So the way I like to describe these is you're going from mass to energy, or you're going from energy to mass. So they structure the question asking, if you have this much mass of this component, or this much mass is being produced, how much energy is released or absorbed from that reaction. They could also flip it around the other way, and they could ask you, if you have this much energy, how much of this product are you going to produce, or how much of this reactant do you need? So I'm showing you one direction, and then on Monday next week, I'll show you the other direction. This is, let's see what we're looking at. Let me get a pen. Okay. So once again, we're talking about Freon because that was the theme of this kind of test in 2022. So Freon has been identified as contributing to the ozone, or the hole in the ozone layer. So it was banned in 1987. In the upper atmosphere, Freon 11 causes decomposition, aka the breakdown of ozone, which is O3. The overall reaction for decomposition of ozone into oxygen gas is shown below, which is there. And they want you to calculate the amount of energy released when 126 grams of ozone is decomposed into oxygen gas. And they've also given me the enthalpy value, and they've given me the molecular mass of oxygen as well. So from reading this, the amount of energy released, we are going from mass to energy is the way this question is formatted. I also can see that they've given me mass as a starting question. So that's how I know it's that way around. Are we okay with that so far? So that's the big hint. So it just helps you figure out the order of which you're working in. I have picked this skill up from my physics teacher when I was in high school, and so I'm teaching it to you guys now because I think this is the best way to organize your thoughts and also to make sure you don't make a stupid mistake. So what I do whenever I'm tackling these questions is I list out my knowns, I list my unknown that I'm trying to solve, and then I list what equations I need in order to solve that. That is the order that I think about these things in, and that's what I would recommend for you guys to do as well. So first off, let's list out our knowns. So what do we know? So I know that my mass of ozone, so my mass of O3 is equal to 126 grams. So that's something I do know. And I got that from there. I also know that for this reaction to occur, the decomposition, that is my delta H. So the delta H of this reaction is equal to negative 285 kilojoules per mole. Is that an endothermic or exothermic reaction? Exothermic because it's negative. All right. The last thing I then know is the molecular mass of oxygen. So back when we did titration, you guys had to calculate this, but you don't have to calculate this because this is given. Actually, did you? I think you did, actually. I think we gave you it. All right. So the big M for oxygen is 48.0 grams per mole, which is also good news. So that's just basically all we did was we took the molecular mass of oxygen and times it by 3. So this is 16 times 3. We good with that? Okay. So now we got to figure out the unknown, what I'm trying to solve for. And the unknown that I'm trying to solve for is the energy release. Let's look actually at the equations they give you in your resource book, level 2 chemistry resource sheet or booklet, just so you guys know what you're doing with the equations. So you do get this resource on the exam. They give you, oh, they're so kind. You know the mistake I made yesterday? You wouldn't have made that mistake because they give you the equation. I thought they didn't give you the equation for that one. So they give you that bond energy broken minus the energy made. Okay. They've given you the moles to mass conversion. They've also given you the concentration equation as well. Every so often they do a question that is on volume. On concentration. I'll try to find one of that. They don't often do that. So what I'm looking for this, my unknown that I'm trying to figure out is I'm trying to figure out the energy release. Which doesn't have a nice little symbol. It's just something that I'm thinking about. And the reason why it's energy released and not energy absorbed is because we are dealing with an exothermic reaction. Are we good with that so far? All right, cool. First step is I want to convert my mass into moles, because we know this equation here is dealing with ratios and we're dealing with moles over here as well. So that's the reason why I'm doing that first step there. So when I think about what equations I'm going to need, the first equation I'm going to need is the N equals little m over big M. So I need to convert it into moles because I can see that this here is in moles as well. This is why I'm talking about grams to energy conversions. So luckily, again, the equation is already set up. I don't have to manipulate the equation in any way. I go N equals 126 grams, and then I divide it by the molecular mass of 48 grams per mole. I personally always write down the units because it's a good way for me to idiot check myself to make sure I've done my math correctly. And I did this when I was your age in high school for physics because I really struggled in physics. And the way that I got through it was I understood the math. I couldn't tell you the theory. And the way I knew how to do my math and how to manipulate my equations is I was looking at my units and seeing how they canceled out. So I see my grams and my grams cancel out, and I see I have per mole. So you see how you're underneath the division sign and you have mole to the -1. So if I have per mole, it goes to now moles. So I know I've set that up correctly. So we are doing 126, and we are dividing it by 48. And so my N value is equal to 2.625 moles for my ozone. All right, I'm going to switch to a different color because now we're starting to look at another step. Are we good so far? All right. So like I said, I want to figure out energy. So my energy release is going to be in kilojoules, but currently I have nothing that is in kilojoules. I do see here I have kilojoules per mole. And if I can multiply this by my moles will cancel out and I'll be left over with kilojoules, which is what I want because that's my energy release in my final answer. However, there's a small problem. Done? Yes. There's a small problem though, and then that is my equations, and this is when stoichiometry comes into place. When we have an equation like this that says kilojoules per mole, we're talking about 1 mole of the overall reaction. But in reference to what we are looking at with the ozone, we are thinking about how much energy is released in the context of the ozone itself. So we need to use stoichiometry and we need to think about these coefficients that are in front. So what this is actually saying to me is that for every 2 moles of ozone, this is how much energy is going to be released. So I need to convert that into being 1 mole. So if I want it to be 1 mole, then I divide that by 2. So I have -285 kilojoules per mole. I'm just dividing it by 2. We're not actually changing any of our units because we're just dividing it by 2 to fix the ratio. So 285 divided by 2, and I get that that's going to be -142.5 kilojoules per mole. And like I said, that's in reference now to the ozone. And now I can put together the final step. So like I said, think about those units. Think about how those units are canceling. So I would take my N and I would multiply it by my delta H. And that's how I figure out my energy. So N is 2.625 moles. And again, I'm multiplying that by -1425 kilojoules per mole. And again, by doing that, the moles and the moles cancel out. So I'm on the right track. So 2.65 times 142.5, and I get from this reaction, there would be 374.0625 kilojoules of energy released. I want it in 3 significant figures just to be on the safe side. Sometimes they want it, sometimes they don't. So let's do it for the safe side. So that'd be 375 kilojoules released. And that's my answer. So use those units. That's a nice little way to figure out what you're doing. Oh, it's blurry. Yes, I see. There you go. Questions, concerns, or comments? Oh, I do. Here. Yeah, Josh.
Where did you get
2.25? What do you mean 2.25?
the one that you found
The 2.625. I got that over here. So I took the 126 and I divided by 48 because that's this equation here, the mass divided by the molecular mass. So that was my mass of my ozone. That was the molecular mass of ozone. And that gives me the N value because I want to get it in moles because nothing makes sense if I don't have it in moles. Sorry, it keeps going blurry. So that's where I got that number. And that's my final answer. All right. I'll show you the marking schedule. This one doesn't have that many steps to it. So this one only goes up to, did I close it because I'm a smart person? Found you. All right. I think, no, it was this, no, next one down. Here we go. See, right answer. One step of the process correct is the achieved. Correct answer is the merit. It doesn't actually go up to excellence, this one, and it has no specification saying you need to round it or use your units, but do it just in case because that's usually where the excellence distinguishing, how we distinguish the excellence from that weird nitpicky detail. All right. So this one I would say isn't too bad because it's not that many steps. There are more. There is another one that I'll do next week, which is same sort of setup, but now we're going from energy to grams, and this one they do actually go up to excellence. So we'll look at that one next week. I don't want to overwhelm you guys. Yep. What's the question?
Why didn't you, like, what?
Oh, I rounded up. Sorry, I didn't mean to round up. That should be a 4. Why didn't I put the negative? Because I implied it with the release. Yeah, I'm just saying it's released. That should be a 4. Sorry, I rounded up when I shouldn't have. Cool. All right, so my recommendation following up from this is there are some SciPad pages that correspond. Oh, wait, what? Did I not copy and paste this over? My goodness. Oh, no, I did. I just was on the wrong page. Okay, so, oh, no, that is markers. Okay, so there's some things you can do. First off, there's SciPad pages, which actually I would recommend this time around. I usually don't recommend the SciPad pages for the calculations because you can't really scaffold calculations, and on top of that, you're better off just practicing the actual exam questions then. But I do find that these ones are simpler, so it's a little bit easier to kind of wrap your head around. So they're nice beginning questions. When you're doing those questions there, just be mindful that some of them you're going to skip because they're going in the other direction of energy to mass, and we haven't done that yet. But you're welcome to give it a go if you want. Other options, you can work on the no brain too small energy-related questions. Just be, again, mindful, trying to go through it and find the ones we've covered so far. So you guys can do the bond calculation ones, which is from yesterday, and you guys can also do this mass to energy calculations. So you can basically do 2/3 of what is a no brain too small. Cool. That's us. So I won't give you a CPR quiz. This is a 2-session lesson. So next time when I see you guys on Monday, I'll give you a CPR quiz that is tied to this because I didn't feel there was a point to until you learned all the math. So those are the 2 types of calculations. Cool. All right, that's us.